To explore the idea of hybridization, I'm going to look at the question, how can carbon form 4 bonds? If we imagine carbon, it has 6 protons. And then if we do its energy level diagram for the electrons, that we're assuming it's neutral with 6 electrons, then we have 2 1s2 electrons, 2 2s2 electrons, and 2 electrons in the 2p shells. So when we look at this structure, we think to ourselves that maybe it could form 2 bonds by bonding with something like hydrogen here and here, but it doesn't have an electron to offer here, and this is a full shell, so that wouldn't want to share either. So really it kind of looks like it should form 2 bonds. But we all know the molecule CH4. So we know that it forms 4 bonds. So how is it, or how does it change such that it's prepared to form 4 bonds? Well, 2 processes happen in hybridization. 1, electron promotion. This is when an electron might be moved from a lower energy level to a higher energy level to make space to form the number of bonds that the atom wants to form. Secondly, shell hybridization. Instead of the shells remaining as an S shell and 3 P shells with different orientations, what happens is these shells all sort of amalgamate and form a new shape. The new shape is based on the idea that all of these electrons want to stay as far away from each other as possible. It's also based on the idea that all of these bonds should be at the same energy level, some common energy level. So, 1, bonding sites spread out as much as possible. And 2, all bonded sites go to the same energy level. For these new sites then, we give them new names. So the 1s2, the lower energy level electrons, are left alone. They don't participate in this process. But the 2 level electrons form new shells that we call sp3 shells. The sp3 name is based on the idea that this shell is built out of 1s shell and 3p shells. Since there's 1s and 3p, that means that I have 4 total shells to work with. And having promoted 1 electron, we now have 1 electron available in each of these shells. This means that hydrogen atoms can come along and bond with each of these individual atoms, or each of these individual sites. The sp3 hybridization specifically, when we have 4 things that are trying to get as far away from each other as possible, looks like a tetrahedron. This is almost like a tripod with something sticking out of the top at the same time. The bond angle here would be 109.5 degrees. And the hydrogens would share electrons directly in between the 2 atoms in a bond that we call a sigma bond. So that is why, or how atoms hybridize, and how carbon can form 4 bonds. To think about why they do this, well, these new orbital shells might be a slightly higher energy level than the pre-existing s and p shells. The fact that they can then participate in covalent bonds means that the overall molecule goes to a lower energy state. And so the situation is favorable as long as there's an atom to bond with each one of these new bonding sites, so these new hybridized orbitals. So that's what hybridization is.